Hello everyone, this is Sam Reynolds doing a review of problems from homework 4.3 for ECEn 240 and 301 to help you guys review for your midterm 2. These sets of problems come from homework 4.3. This is problems 4 and 5. This is really 4 through 7. I'll do 4 and 5 for you guys, and then you can do 6 and 7 on your own. This is the problems where you have the successive approximation register hooked up to the digital analog converter. And in this case, we are given a reference voltage and input voltage. We have it hooked up to a comparator op-amp, which you guys will review in your Unit 5 homeworks. And we need to see if, for number 4, what happens with the binary output of the SAR if Vn is 5 volts, and for number 5, what happens to the output of the SAR, the binary output, if Vn is 2 volts. So, in order to start solving this problem, we have to identify 3 things. What is our reference voltage, how many bits do we have, and what is our input voltage? In this case, for this problem, we are told that we're using a 6-bit analog to digital converter. I actually wrote that wrong. Analog to digital converter, there we go. The analog to digital converter is inside the SAR, and then it gets fed into a DAC. There we go. So we have a 6-bit analog to digital converter. We have a reference voltage of 11 volts, and our Vn for 4 is going to be 5 volts, our Vn for 5 is 2 volts. Now that we have identified those 3 things, to make things a little easier, I recommend taking your reference voltage, and based on how many bits you have, do your reference voltage over 2 to the 1, 2 to the 2, up to however many bits you have. So in this case, I have 11 divided by 2 to the 1, 2 to the 2, all the way down to 2 to the 6th. And this is going to be very important for solving the rest of these problems later. In order to solve these, we need to use the same logic that this comparator op-amp is going to be using. So for number 4, for example, we have this binary output of 011-101. So how do we get that output? Well, we take our values, starting at the 2 to the 1 bit, and we say, okay, is this voltage going to be less than the Vn or greater than the Vn? If it's greater than the Vn, we toss it out and we put a 0 in its spot. If it's less than Vn, then we keep it and we add a 1 in its place. In this case of bit number 3 on this one, we start off with 2.75 in bit 2. That is less than 5, so we keep it and we move on. We, instead of checking to see if just 1.375 is going to be less than 5, we now add it to our running total. So if we add these two together, we see that it is still less than 5 volts. So we put a 1 in its place and we move on. And we keep doing that with the rest of these. Now, in the case of bit number 5, if we added the 5th bit value to the running total of values 2 through 4, we would see that it would be greater than 5 volts. That's not what we want. So we throw that out, put a 0 in its place, and move on. And it turns out that when you add this last 2 to the 6 value to our running total of 2 through 4, we see that it is less than 5 volts. It's approximately 4.984375. And I drew out a little long explanation of, you have all the values, cross out the ones, you can check your math and make sure that this adds to indeed less than 5 volts. And we have our binary output of 011-101. The same thing can be said for number 5. If Vn is now 2 volts, we have a much smaller starting point, which knocks out bits 1 and 2. So we start off with 2 zeros in the binary output. When we get to bit 3, we see that 1.375 is less than 2, so we keep it and we move on. I'm going to write that there. So 1.375. And then, if we added 1.375 with 0.6875, that would be more than 2, so we put a 0 in its spot and we move on. And it turns out that bits 5 and 6, when you add these together with bit number 3, like I show in this long list here, so we have bits 3, 5, and 6 all added together, it's 1.890625. And that is less than 2 volts, which means our binary output is going to be 001011. And I would implore you guys to do problems 6 and 7 of this homework to further review, and also do the first few problems so you know about ranges, whether signed or unsigned. And you guys are going to do a great job on your midterm. So that is the review for homework 4.3, problems 4 and 5. Good luck.